In this session, we're going to talk about how to use Python to do your raster analysis. The title is very simple, working with raster data, but that covered pretty much the whole spectrum of raster analysis and data management and some aspect of it. My name is Noman, Nawajish Noman. I go by Noman, and my colleague Liz. We are part of Spatial Analyst extension. So, quick question here. How many of you have used Spatial Analyst extension? How many of you have used Grade in your life? Okay, Grade is the ArcInfo product, and Spatial Analyst is the next generation of Grade. Some of you probably know. So a lot of things are been around for a long time. Anybody used ArcView? Okay. So we have a very nice mix here. So, okay, let's get started. I'll probably have to sit here and talk because I cannot walk and see. So let's see. What are we going to do here? We're going to talk about raster analysis, but to explain some aspect of raster analysis, we have kind of divided into a couple of sections, and we will use a demo or a modeling demo really to show you the capability. And we'll talk about that a little bit. So initially we'll talk about how you can manage rasters with tools, and you can perform analysis with Map Algebra. That's kind of the umbrella thing. And we'll divide that, and through some examples and demonstration, we'll show you how to access that analytical capability, how to write complex expression and optimize it, and then additional modeling capability if you want to do something additional analysis. But at that point, you might find that, okay, you want to do something that is not available in the toolbox, and what can you do to even do that kind of analysis? And finally, we'll talk about multiprocessing a little bit, because these days we are dealing with large data. Those days are gone where your raster was 1,000 by 1,000 cells. Those days are gone, right? Okay, so I said that we will teach all of these things through a modeling problem so that you can look at different aspects of these capabilities, right? So we have a complex modeling problem where you'll be working with raster, features, and table. Now, how many of you have used geoprocessing tool? Probably all of you, kind of. How many of you actually use Python to do your work? Okay, so the question is, tool dialog versus Python, why should I use it? If you are using Python, I don't have to convince you why you should do it, but just to recap why we do this kind of thing, because it is reusable and dynamic in some cases depending on the analysis. It extends the capability, because if you want to do something, your tools are not there, what do you do? And it performs really well because in many cases it's optimized in a different way. Okay, so that is why you want to learn Python, and you want to do your analysis using Python wherever you can. That doesn't mean that you will not use tool dialog or model builder. I'm just saying this is another efficient way of doing things depending on the work you are doing, right? I always say, build up your prototype in model builder and then start, go to production code or write production code, something like that. Okay, the model that we are going to use to explain all this thing is the Ashburn model, and we have divided this analysis into different parts so that we can actually demonstrate the capability of ArcPy and raster analysis. Now, when my colleague Liz goes over the model and explain you what is happening, my request to you is not to worry about the model part of it. That is it really correct? Is that how a bird fly, or is that how far it flies? Don't worry about that part. That's not the point of this demonstration. We are actually using that concept to teach you the Python part of it and how to apply that to do that kind of analysis. So, when you are in doubt, focus on the Python part, don't worry about the modeling part. We can also talk about the modeling part if necessary, but that should not stop you from understanding the Python capability, right? So we have divided that into a couple of sections where we're going to show you how it moves by flight, right? That means it's fly from one place to another on its own power, and where it will it will land or where it will actually destroy the tree depend on the vegetation type and everything other criteria, right? So we will try to take that into account in our analysis. It also moved by hitchhiking, basically, near the road, jump on a car, going there, or from a mills where you have logs, sitting on a log, moving one place to another, and now then from there it flies again. So we will try to take those kind of scenario into account to show you how you can do those kind of operation using raster analysis, right? And then the last part is random movement. Just goes from one place to another, and we cannot really tell how it got there. So it's kind of the random nature of that analysis. So we will show all these different parts of your analysis and show you how to do that using raster and Python. That's the whole point, right? Okay, so now let's talk about raster analysis. Why we want to do raster analysis? To prepare and manage raster data in that realm. What are the things you do? You can do display, you can add, copy, delete. You may want to create a mosaic clip. Anybody has done any real project, we all know that data preparation is a significant part of that work. And if we don't do it early on correctly, downstream we suffer a lot, right? We don't understand the result, blah, blah, blah. I don't have to tell you that. So we'll talk about Raster Object in that context, and then we'll talk about NumPy and apply environment. Now, so that's the data management part through which you can do all this thing, and then you want to do analysis. We are from analytical team. We are part of the geoprocessing team, Spatial Analyst. So we love analysis. For us, analysis is the GIS, right? So how do you do analysis? You use the Spatial Analyst extension, and within that, we use Map Algebra, and we'll explain Map Algebra later, to do the operation. So the focus of this session is all around those kind of things, right? Now, what is Map Algebra? What is Map Algebra? Okay, is there anybody here who has not written C equals to A plus B type of expression? Everybody has done it, right? So Map Algebra is that kind of expression for raster analysis or in spatial analysis, because if I only say raster, that leave out the feature part of it, but you can see that we can also include feature, right? But Map Algebra expression is really powerful when you write a very complex, compact raster analysis expression. So we'll show you how to do that. And it is a simple and powerful expression that kind of incorporate spatial analyst tool, operator functions, those kind of thing, and you are performing analysis. The strength is in creating complex expression. You don't want to do one click at a time, one tool at a time. It is realistic for school homework, and beyond that, it becomes a little tedious if you have a complex problem that you're solving, right? So this is where the strength comes in. And where is it available? In extension toolbar, toolbox is easy to find out, right? It's under Spatial Analyst tools. But in Python, where is it coming from? It's coming from a module called Spatial Analyst module, and of course, short and sweet SA module, right? And it's integrated in Python. All modules are available, right? So now let's move on. And how do you actually access this Map Algebra, right? There are many ways to get to this thing, right? Some people still want to do UI, and I don't mind doing that because sometimes it's easy, especially if you want to do Map Algebra expression in a model, you have to do that. But we still want you to write a Map Algebra expression, a Pythonic expression, and you can do that in Raster Calculator, right? But this raster calculator is not the same raster calculator we had in 8X. Same name, similar capability, completely different implementation. This raster calculator actually execute Python expression, right? It's actually Pythonic, and you can access Spatial Analyst tool. It has easy to use interface like the old raster calculator. You know, somebody still want to click 1, 2, 3, 4. Some people are really adamant about it, right? I said, okay, fine, you'll get your keypad, right? And then it has area where you actually write your expression and you execute it. We optimize internally, we check syntax, we do those kind of things. There are another place where you can actually do this Python thing, as in Python window within the app. In Pro, in ArcMap, you open a Python window, you write this expression. Another place, of course, outside of everything, you write your own Python script and get it going, right? Okay. So of course, to do that, you have to import this module, the Spatial Analyst module, right? So you have to import module of ArcPy, and like all modules, it has to be imported, but this is where we throw a little bit curveball and say, you know what, if you're a Python ninja, you say, I want to import it this way instead of that way. So instead of getting into that argument, what we're going to say, look, import your ArcPy, and this is the expression from ArcPy import environment. This kind of expression you can use to import your environment. But as far as the Spatial Analyst module goes, we recommend to use this kind of expression where from arcpy.sa import star. It says best practice for Map Algebra. And many people will say, oh, no, that's bad from Python, pure Python standpoint. And I agree with you. I'm not going to disagree with that. But there is an advantage why we do that. We say don't do this because it's not recommended. Part of the reason is when you are writing a Map Algebra expression, you don't want to use namespace again and again. It's become unreadable. So it will execute and whatnot, but if you start writing it, you will see why this one helps a lot. And also another important thing is the operator, and we will explain that a little bit more in a minute. What is the general syntax? General syntax is pretty simple. You write an expression where your output is in the left-hand side, like C equals to A plus B, and all your inputs are on the right-hand side of the equal sign, right? So that's the general thing, which is different from other geoprocessing tools that you use. So that is most important thing to note from the get-go, because I still see, even after 10 years, that people, we say, do it this way, and they will write it in another way, right? And that is not efficient for other reason, and we'll explain that some of it. So the form becomes like this, right? You have output on the right-hand side, you have your function and inputs going on, right? And it has your input data, operator, tool parameter, and output. That's the kind of the thing. Okay. And what are the inputs that you can use? Of course, raster, feature, number, text, constant, objects, variables. We all know that. Here is an example in this expression where this is slope tool, raster, text, number, all coming in as an input to your data set, right? What are the operators? Of course, everybody knows what operator, plus sign, minus, multiplication, all those mathematical operators. We have tons of them, right? Bitwise and stuff like that. And you can write this kind of expression. If you did not use that star way, import star that way, you cannot do that, right? And then if you are working with a raster, you have to actually cast it as a raster object, and we'll talk more about it. So here's some example, right? Adding two raster here, adding a raster with a number, and taking the output of one expression and doing another expression. So you will see in the example, we'll do a lot more of those quickly. And Map Algebra tools, right? All Spatial Analyst tools that output a raster are available here. And you can also use any geoprocessing tool, right? By the way, these tool names are case sensitive. A quick overview with the tool parameter and everything. You see, I have this 1, 2, 3. What are the things? It's defined how tool is executed. Each tool has a unique set of parameters. Some are required, some are optional, and it could be number strings and everything. Over here, you see the tool. You have the input, output, another parameter. In Python, you have exactly the same thing going on, right? So even looking at the tool parameter, you can pretty much figure it out, what is happening, and you can map it, right? And the Map Algebra output, it returns a raster object. It has properties and method, and the output is temporary. Important, the output is temporary, and we'll talk a little bit more about it. With that, I'll hand over to my colleague Liz to show you how this basic Map Algebra works.
Yeah. Thanks, Noman. So throughout today's demonstrations, we're going to be modeling the emerald ash borer. This is an invasive beetle that kills ash trees. My study area is in Vermont, and I have some data I'm going to introduce you to. I have some campgrounds because the concentration of this beetle is higher, closer to campgrounds because of the campfire wood that people bring in and just the activity around them, as well as mills because of the lumber along major roads, because not only do the emerald ash borers fly, but they're on the lumber and the firewood that's being transported, and sometimes they fall off along roadways as they're being transported on this wood, and then also urban areas. So I'll be using this data throughout today's demonstration. Also, you're looking at some elevation data. So let's go ahead and just cover a few of the things that Noman already introduced to you. First of all, he showed you some expressions that were screenshots from the Python window right inside the Pro application. So this is the Python window. I accessed it from the Analysis tab and just clicked the Python button. And in here, I'm going to do my import statements. I actually don't need to import ArcPy because that happens when you, when you open the app. But we import ArcPy when you're in standalone Python. Noman also mentioned a really important import statement when working with rasters and specifically Spatial Analyst, and that's from arcpy.sa import star, or everything. This way we get our overloaded operators, so Python knows, or we can tell Python we want to add together rasters, for example. Noman mentioned that we rely heavily on a raster object when we're using Python with rasters. And to create the raster object, you can cast a layer or a data set as a raster object just by wrapping it in that capital R raster. And now my elev is a raster object, and it comes with a whole bunch of properties that you can see listed here. So if I want to know the maximum value, for example, of that raster object, it tells me it's 4381. So there's all kinds of information I'm able to get off of that raster object. Another thing we do before we do analysis is set some environment settings. So before I run a map algebraic expression, I'm going to go ahead and set an environment setting. So arcpy.env.extent. And I'm going to set that to my study area. Oops. Pardon? Oh, extent. Thank you. There's even I could have just accepted their help and I would have got it right. So now I've set my extent to the study area, and I can go ahead and run an algebraic expression. So let's apply a conversion factor to this elevation raster that I've created, or the raster object I've created. So I can say elev times the conversion factor 0.3048. So what I'm doing is I'm converting from feet to meters, and you can see I have a new elevation raster that's now in meters. And as Noman mentioned, we can use other functions like our geoprocessing tools within Map Algebra, but they have those left-hand outputs. So let's go ahead and run the slope function. To do that, I just use the slope tool where I input maybe my new elevation, my one that's in meters, and then I can go ahead and run that. Noman mentioned a really important thing in his last comments about that left-hand output. He mentioned that it's temporary by default. So if you query a property called isTemporary, you can see that that left-hand output is in fact temporary. And if you want to save it, you need to call a method off of that raster, so off that raster object. So there's a save method where we can save it and we'll make it permanent. So now I've saved that, and now if I query isTemporary, it's false, because I've saved it. One more thing I'd like to point out is where the Raster Calculator lives, because Noman mentioned it. So you can just type Raster Calculator in the geoprocessing tools, or I think you can see here inside the Spatial Analyst toolset, or inside Map Algebra, here's the Raster Calculator. And we could do that same expression. We could say elevation times 0.03048. And then we can run that algebraic expression. So that's a geoprocessing tool that can be used in a model, and it does Python natively as well. With that, I'll turn it back over to Noman.
Thank you, Liz. Let's see. Okay, so you know how to run the expression using Raster Calculator, also in Python window. Now, let's step back and slowly think, about some of the kind of the words or jargon we have used, and what does it really mean? One of the things we keep saying, complex expression, what does it really mean, right? C equals to A plus B is not a complex expression. That's pretty simple, right? But when you are writing, something in a really long expression that, have operators or tools, then eventually it gets a little complicated and complex. Now, why you want to write in one expression, there is a reason for that. Sometimes it is easy to understand what's really happening, but there is some optimization going on, and we'll talk about that a little bit. Now, one important thing is that you can actually break it apart into multiple expressions and take the output from here and use in another one. Still, the optimization will happen unless you forcefully save the earlier one, right? So when you are building complex expression, you should actually think about what you need from the intermediate result and whether you should save it or not. That will play a big role how you are constructing your expression, as well as how you are actually passing the output from one expression to another expression, right? Okay, now we said that raster object, that is the most important thing in Python when you are working with raster, right? It's an object that points to your raster data set. That's it, it's a pointer, in a nutshell. But it's a very powerful pointer. Usually an output from a Map Algebra expression is a raster object. And then you have to save it if you want to persist it, otherwise it will go away along with your output, right? That is why it is associated with a temporary data set, and it has a save method so that you can do it. A series of properties you have. Anybody from grade time, somebody may remember some $, those variable to give you a number of rows, number of columns, cell size, or statistics. We also have actually geoprocessing tool that returns raster properties. Now all these different ways, or you have describe that gives you those properties. All these different ways of doing things, you don't need it, because raster object gives you everything that you need to know about your raster. You just have to ask for it and get it. That's why raster object is a really powerful thing. And I talk about the optimization part, so let's hit on that a little bit. So where the optimization is happening, it is happening with operator and local tools. So for example, you want to do A plus B times C. Now, it's not that we're going to do B times C and create an output first and then add to A. If you're running a geoprocessing tool one by one, that's what will happen. Not needed, right? When you write that, we will look at the expression and we will compute everything in one shot. So I gave you a simple example, a plus b times c, but you can imagine it could be a really complex expression with cell statistics in it or something else going on, and the whole thing will be done in one shot. Isn't it beautiful? There goes your performance up, right? From creating all intermediate chunk versus, in one shot you are getting your output, right? This is where the optimization happened. Now, you also have to think about it a little bit. Sometimes most of the time we'll try to avoid creating the data until you need it. So it's called deferred evaluation. However, when you start calling some properties that really require the data set, then it will trigger the creation of data set. So even though you may not save it, it may create the data set. So then, don't say that no one was lying, because I'm not lying. I'm just saying that we don't create it unless we need it. It's an internal thing. Usually save will trigger it and persist it. But there are some other situation can trigger it also, where we need that data set to give you what you are asking for, right? So that has to be mindful. So, which also means that if you don't need those information that is triggering your data set creation, don't just for fun, don't just start printing out those information, because then it will trigger all this creation that you don't really need or want, right? Okay, and now we're going to go back to our model where we're going to do the movement by hitchhiking, where Liz will explain what are the things we're doing. Especially, we're checking some random points, and then we're also, modeling nonlinear decay, and she will show you how we're doing it using Python.
Thanks, Noman. So before I show you the script of this analysis, I've done a model which hopefully will be able to better see what we're going to do in the script. So I showed you I have campground data, mail data, urban area, major roads, and then these are emerald ash borer's current location. So I have these data sets, and what I want to do is I want to find likely places where the emerald ash borer will hitchhike to. We said it's close to campground, close to mills, close to urban areas, and close to major roads. So what I did is I ran a tool called Euclidean distance, which calculates the distance from something to everywhere in my study area. So for example, the output of this Euclidean distance is a continuous raster showing every location across my study area, how close it is to a campground. Then I ran a get raster property to get the maximum value, because what I do next in this Raster Calculator is I do a nonlinear decay function showing how likely it is that the emerald ash borer will be there. So it's more likely to find the emerald ash borer closer to the campgrounds than it is further away at a nonlinear rate. So I use this power function. Again, we're not trying to teach you how to model an emerald ash borer. We're trying to show you how Map Algebra works and what it looks like. And this is a complex algebraic expression, which is using a power function, a division in one step is what we want to show you. And I'm going to do this for each of my inputs, and then I'm going to combine them, and again I use a Raster Calculator, in a weighted expression where I have each of them saying how relevant they are in relation to one another. Campgrounds are highly significant to the emerald ash borer, where urban areas are less significant, so it gets a smaller weight in my expression. Again, don't focus too much on the suitability analysis. Just recognize that this is a very complex expression that has many additions and multiplications and a division by the total number of weights all at once. And if you did this in separate geoprocessing tools, as Noman was saying, is every time if you use the plus tool and the multiplication tool and the division tool, every result will get written to disk. But because this is one algebraic expression using local function, there's deferred evaluation. And only the final result is written to disk, and only if you ask to save it or query a property off of it, which requires it to write to disk. So that's what's really important here. So after I get this, what we call a suitability raster showing how likely it is for an emerald ash borer to end up in a specific location, then I go ahead and do a little bit more work in my model, and I say, well, are are there any ash trees there? And if so, like if it's a highly likely location that the beetle ends up there, then I find out if there's any tree there that it likes to eat, any ash tree, and if it is, then I infest that location. And so then that is one iteration of this model to show where the emerald ash borer is going to hitchhike to. So let's go ahead and look at this in a Python script. So this is exactly the same model, just written out in scripting instead of a geoprocessing model builder model. The first thing I do is I do my import statements, import ArcPy and import from arcpy.sa import everything. I can't stress how important that import statement is. Next, I check out my Spatial Analyst extension so I can access the functionality. I set up my work folders. And then I do my environment settings. This is important for raster analysis. I set the extent. I showed you do that earlier. The snap raster and the cell size are also set at this time. And then I go ahead and I list my input data sets. From there, I'm getting ready to do my simulation. And if we hop down from here, you can see where I have my weights listed. These are the weights I'm going to use to apply to each of those. You saw that in the Raster Calculator. And these are my data sets. So I have a couple of lists here. I list my input data sets and I list my input weights. And I'm going to do 3 iterations of this loop through this model. So starting here for iteration 1, you can see I do the Euclidean distance. I find the maximum value. You saw me do this in the Python window earlier. And then I do my nonlinear decay function, like you saw earlier. And then I combine all that, and I loop back through my model, and I do it multiple times to find the newly infested area. And I set it to infested only if it's susceptible, and there is a highly likelihood that it hitches there, and that there's an emerald ash borer there. So let's go ahead and run this model, and then we'll take a look at those results and see what happens. So these red areas are where they're currently infested locations, and that's one of the inputs to my model. You can see I'm iterating through here. I did simulation 1, simulation 2. I'm now on simulation 3. These results are being output to my output folder over here. And you can see these are the new locations, these new dots that are here. And those are my next ones. And this is from the 3rd iteration of my model. So each time I ran the model, I found newly infested locations just by looping through. So I was able to really dynamically, use Map Algebra and Python to do this type of raster analysis by doing lists and iterative process and complex expressions with deferred evaluation. I queried some, raster properties. We just wanted to show you how that all comes together in a model format.
Thanks, Liz.
Thank you, Noman. I've zoomed into a couple of the infected beetle locations. And from now, we don't want to know where they're going to hitchhike to. We want to do an analysis of where they actually fly to. So I've created this model over here, and I've used this focal statistics tool that Noman has introduced you to. It lives here in the neighborhood tool set. It's called focal statistics. And there's this complex parameter we have here. He mentioned the circle that has a radius and a units type. I'm going to use one that's called a wedge. See, the thing about these emerald ash borers, if they've already infested everything to the south of them and they are only moving north now. So I've set the location for where they're going to fly to a wedge from 0 to 180 to restrict where they can possibly move next. They're not going to move south. We know that because that area is all devastated and infected and there's no ash left down there. So their next movement is to continue to move south. So I'm going to use this class or this complex parameter to restrain where my model is going to show the emerald ash borer fly to. And then I can set how far they fly by using the radius. And that's going to change for different seasons, right? They're most active in the summer. They're less active in the spring and the fall. So that's what this model is going to show, how far they fly And if they get to that location, is there an ash tree? They'll infest that location. We'll run the model again. And in the summer, they'll fly further and infest anything in their path that has an ash tree, etc. So we're going to loop through. So I'm going to run this focal tool to find out where they get to. Then I have a raster calculator expression that just again says, is this location susceptible? Is there ash there? And if so, infest it. So again, we'll look at this in a script. So if I scroll up, you can see I do my import statements, I check out Spatial Analyst, I set my folders, I set my environments, very important every time you do an analysis. And then down here, you can see I have my distances set. So in the spring, they fly 5 cell units, in the summer 20, and in the fall 10. So I have a dictionary set up here with those values. And then moving down, you can see when I create my neighborhood class, I can get those different seasons, the values for those different seasons, and then I have my wedge set up from -180 to 0 so that I control the direction. So I'm creating a neighborhood wedge class using the values from this dictionary, and I'm going to loop through that, so it's quite dynamic. Then I run my focal statistics tool to get that information using that wedge, and then I have this complex con expression where I find out what gets infested, if it's a susceptible location or not. So let's go ahead and run this, and we'll iterate through this model again 3 times, once for each season, having the flight simulate go the respected amount. So if we come back here and we go to my output folder, and I refresh, you can see in the spring, and then in the summer, they move much further, and then in the fall, they move a little bit more. It should be underneath. You can see, so you can see how much they move each time. They move just a little bit, and then they move a lot in the summer, and then they move here. And you can see there must not be much to infest down around this point, because that con statement would have not allowed the emerald ash borer to land at that location or become infested in a location where there isn't any ash tree. So this is simulating the movement of the emerald ash borer by flight through different seasons by using that class example. And we just wanted to show you how you can use these classes to easily iterate within your analysis.
Okay. Thank you, Liz. Let's switch gear here. Now I'm going to introduce a very simple concept, a very simple thing. But I can guarantee that this simple concept will change your life. Well, not your life as a whole, but your life in raster analysis, right? And you'll see it, why is that important. So before I talk about NumPy, we all understand what is an array, right? Array. What is a raster? A raster is nothing but a huge array of values, right? Rows and column, bunch of values, right? Arrays. Like you look at it in Excel or anywhere, you can write down a bunch of numbers. That's what it is, right? So now, in Python world, there is a one nice array thing, and package to manipulate and manage array and do a lot of fantastic thing with array. That's called NumPy, right? We call it NumPy array, NumPy package, right? NumPy, whatever you call it. So it's and we actually ship it with our product. When you actually install, you get it. Now, the trick here is to take advantage of that and all the operation that comes with, right? Like linear algebra, filtering, clustering, optimization, Fourier transformation, morphology, whatever you can think of, advanced image processing, different image processing, different analysis. You can take advantage of all of these while you are doing your analysis. How do you do that? That's the question, right? How do you do that? You do that by using this simple function. Because the challenge is here, I have a raster, I need to turn that into an array. And then I'm going to do a lot of fancy thing, Now once I'm done, I just want to turn it back to a raster. That's the simple two-step process. And you can achieve that two-step process by using these two functions. The first one, raster to NumPy array. Duh. Simple statement, right? What it does, it takes a raster and then some other parameter. Those are optional, like those curly bracket. Those are optional. Forget it. It will give you an array, and you can send that to wherever you want to send it in NumPy package or other SciPy package and do some fancy operation, right? And now when that operation is done, you have an array with output, and you just want to turn it into a raster. What do you call? NumPy array to raster. Done. Certainly, you have extend your analytical capability from outside of this 150 some tools that we ship with the Spatial Analyst to thousands, millions. Doesn't matter, right? You can do anything you want, right? You don't like our slope, you create your own slope. That's the idea, right? Okay, so we're going to show you how to take advantage of this in a very different way. I mentioned about this random movement that we cannot really model using the Spatial Analyst tool we have. So we want to model that using NumPy array, and Liz will show you how to do that.
Thanks, Noman. So this example, of course, doesn't start within the Pro app, because the whole point of NumPy for Raster to NumPy is that you're expanding the functionality beyond what comes in the box that we give you, right? You're taking it into an array, and then you can use all kinds of different libraries and modules and stuff to do different computations on this array instead of on the direct raster that we didn't give you capability to do. But here's my Python script where I'm going to use these tools that Noman just spoke about. So again, I start with my imports, my Spatial Analyst license, my folders, my workspaces, my environment, set up my variables, the same thing you've seen the whole way around through each of my demonstrations. And then down here you can see I use this Raster to NumPy array tool. My first input that I'm using is my raster that shows already infested locations. And then the second one I'm going to turn into an array is a susceptibility raster. How likely is it to get infested, right? And then what my next thing is I have this function created up here. So if you scroll up, you can see I have my two arrays as input to this function. And then what I do is down here, I use this random function. So sometimes when people kind of truth their models, they add some randomness to it to see how much impact that can have to their analysis, to find out how robust their model is. So sometimes it's important to add some randomness to your model to see if it stands up. And so that's what we're doing here. We're going to add some randomness to where these emerald ash borers end up and see how it impacts our model. And here you can see I've accessed off this random module, this other, the main point is just that this is outside of ArcGIS. This is outside of what we give you in the box with Pro. You are able to extend your own functionality and write your own functions by bringing it into an array, doing your analysis, and then bringing it back using the NumPy to raster functionality after you've done the analysis that you want to do. So that's what this script is showing you, how you can expand the functionality outside of what we give you with Pro. And so through this, if you run the random model once, you get a couple random points, or if you run it again, you get another random point, and if you run it a third time, you get some more random points. So it's just a way to expand the functionality of raster analysis through using these NumPy tools. Thanks.
Thank you, Liz. Okay, so now we're at the last section of our presentation here, where we're going to talk about a little bit about multiprocessing. Now, if you have been doing Spatial Analysis for quite some time, you know we don't parallelize. Well, that story has changed significantly in the last couple of years, right? So within our tool, we have actually parallelized many tools. And when we go to cluster, we can actually do distributed computation. So this section is not about talking about those tools which we have already parallelized for you, or we do distributed computation. This section is primarily for the tools or for some of the operation that you want to do and you want to take advantage of parallel processing and you want to do yourself. This section is actually geared towards that. So before you go start writing this kind of parallel processing or decide whether you're going to do parallel processing or not, please check out whether we are already doing it for you or not. If we are doing it, then there's no reason for you to try to do that again. It's pointless, right? Okay, so before you actually think about parallelizing anything, you have to think carefully what kind of operation you are doing, right? Is it a local operation, means it's actually cell by cell operation, versus it's a focal operation like slope or something where you need to look around your neighborhood, or it's a zonal operation like zonal statistics, or global operation like distance analysis or watershed delineation or flow accumulation. Now, some operations are easy to parallelize, some are not. Stick to local and focal when you go to zonal. Be careful when you go to global, probably not going to happen. But, well, it can be done. We have done it, but it takes a lot of additional work to do that kind of operation, right? So we will stick to pleasingly parallelizable problem, right? Where what you do, you chunk them up and you process and you put it together. Now, many people say, hey, that means I can just chop it into 1,000 pieces and run it and it will go faster. Answer is no. Why? Because doing this work, cutting, putting it together, all these things require some work. Those are overhead, right? And your processing computation might be very quick, but your data I/O is really taking up time. So you have to consider three parts, right? Actually 4 parts. One is reading the data, then chopping it up, putting it together, computation itself, writing out. And if you don't carefully examine the time that's taking in each process, trying to parallelize it by throwing it to 16 processor, 32 core, and all this thing may not be beneficial at all. An example of that is here, right? See, number of processor from 1 to 4, rapid increase, 5, 6, not getting any more benefit. Now, this is for some tools. That doesn't necessarily mean every tool will perform the same way. Depending on the process, you have to try to figure it out. 4 and 6, you can get a lot of benefit. Beyond that, you are probably not gaining much. It's going to go up depending on the operation, the format of the raster, size of the raster, and everything. So there's a complete disclaimer here, right? But you can actually really do cool stuff by taking advantage of it, and you can get things done really faster. You know, you see the first couple of cores, the gain, it's a significant drop, right, in execution time. Here is some example of how you can use the Python to do this. You have to create a pool, process pool, and then you map it and execute. The process of doing this is pretty trivial. Writing this kind of code is trivial. What is not trivial to making the decision, which computation you're going to do, how many pieces you're going to do, and why you're going to do it. And especially when it comes to focal operation, how you're going to deal with the overlapping area. Those kind of discussion is more important than just writing this piece of code. This piece of code is trivial. Okay? So when we talk about parallel processing, think about all the other aspect which is not in the code, which is, how beneficial it will be and how we're going to work with the edges and stuff like that. Okay? And one of my colleague team member, Neeraj, wrote a really good blog about multiprocessing with ArcGIS, Raster Analysis. Here he mentioned about some of the core tool that we have already done, and how, if you want to write it, how you go about it, and what are the things to consider. With that, let me recap what we have done here, right? Here we came to learn how to do raster analysis using Python. And Liz and I have covered all the basic aspects of it. And if you actually summarize everything, what exactly we're trying to tell you, we're saying, hey, if you want to do a modeling and raster analysis, use Map Algebra, right? the more complex it becomes, the more beneficial it is to do that way. Map Algebra is very powerful, flexible, and it's integrated with Python, so you can do a lot of stuff. What are the key ways to access it? Raster Calculator, Python window, model builder through Raster Calculator, and of course the scripting by itself. What are the important things to look for? Raster Object, your best friend, Raster Object, Raster Object, Raster Object, right? Now, we said that the outputs are Raster Object, but we also said you can specify input as Raster Object, where you can actually cast your data set as Raster Object and then do the operation, right? And you can actually write complex model to capture the real world phenomena, what is happening, right? We're trying to capture how ash borer is actually infesting trees and stuff like that. You can also use multiprocessing to improve performance where applicable. Be aware of all the other gotchas, right? I/O speed, number of processing, the overhead of cutting it up and putting it back together, right? And then we have some demos available online. With that, I will open up for question, but please don't forget to take time to do the survey. Okay, questions?
Is there a performance difference from arcpy.sa import everything versus calling it just arcpy.sa.slope later on in your code?
The question is there any performance difference, if I do import and do slope versus arcpy.sa.slope? Now, from tool execution point of view, there is no performance difference, right? The slope tool will run at the same speed, no problem. Most of the benefit, advantage or disadvantage is coming when you are trying to write complex expression, then the readability and especially the operator. How can I specify plus arcpy sa dot plus? That's not going to work, right? So this is where this import statement is important. Any more question?
Are there any memory limitations or size limitations?
That's a tough question, right? The memory limitation, right? So the good part is go to Pro 64-bit, we can take advantage of more memory, right? So memory limitation not coming from the software itself. Most of the time the memory limitation coming from your computer. Oh no, let me take it back. Of course, software itself when it's 32-bit versus 64-bit. ArcMap is 32-bit. 32-bit has its limitation. It can take advantage of more memory. It's operating system, right? So if you go to Pro, that's 64-bit, you're open to more memory. So now you can write more efficiently. Things will go faster because you will see that we don't have to, we can put a lot of stuff in memory and work rather than going back and forth, back and forth, back and forth, right? So it's just the advantage of the environment and the operating system. Yes, sir.
Do you have a link to download the slides from the internet?
I think they will all be available. If not, you can email me and I'll send you. It will be available eventually. Yes, sir.
Can Spatial Analyst use the GPU?
Can Spatial Analyst use the GPU? That's another discussion we're having. We love GPU. So the thing is, we use GPU in the company for various reasons. For display and everything, we use GPU heavily, right? In Pro, very GPU centric. For analysis, we have some Spatial Analyst tool that take advantage of GPU. Now the question is, if the ultimate objectives to improve the performance, do we parallelize, do we distribute computation, or do we take advantage of GPU? And we are trying both, and actually our mainstream development is parallelization using multiple processor and distributed computation, but we're also doing some of the tools with GPU, and we'll probably add more tool to it. But that line, it's almost like rewriting everything. And not everybody has the high-end GPU to do a lot of computation. And as I said, the discussion I had for parallel processing, the same discussion goes there, right? Do we really need to chop it up into thousands of pieces? And if you do, what does that really mean to you, right? So where we are actively doing GPU-based development for analysis, but we have to be careful, where it makes sense, where it doesn't make sense. And that is why, we have to pick and choose. Okay. Any more question? Yes, sir.
For using the NumPy, is it a snap raster environment setting if I want to do multiple rasters and align NumPy arrays?
That's a really good question. The question is, when we are doing NumPy to raster, do we honor snap raster or alignment? Now, I have to double check. Liz, do you remember whether, however, I have to check the page where snap raster is honored or not. But I want to tell you one thing from the upfront, that when you are actually trying to create, okay, what does snap raster do? Snap raster actually move your cell a little bit and align, right? I'm not really comfortable when I'm trying to do that when I'm creating array, because if I'm doing any analysis, I better make sure my rasters are all aligned, and then it's almost like I'm gonna take this array out and process, put it back, and at that time I'm not letting this snap raster moving my array around, right? That's probably not a good practice, even though if we support, sometimes we support many environment, because some users say, I don't want to think, I just want to execute it, right? But I don't think going from raster to array and array to raster, you want to be very careful which pixels we are actually picking up and operating and putting it back, rather than let environment throwing stuff around, right? Okay, cool. I think, I can see my colleague is here. Probably he's going to take over this room. So unless you have any last question, any last question? No? Okay, thank you for attending the session. I'll be around and we can answer the other questions.